Hi, welcome all on Jim's Orbit, and we have covered in real number part 1 till the LCM finding method, and we have covered only one method. So there is one more method to find the LCM, and today we are going to take that method. Okay, now consider that we have two numbers 90 and 144, and we have to find its LCM. Now we can do the prime factorization of them two numbers separately, or we can also apply the prime factorization, but this time we will be taking both the numbers at a time. So what we have to do, we have to take a number, a prime number, so that it divides both of these numbers. We will begin with the smallest prime number, which is 2, and we'll move ahead. So this will be 45, 72, then this will be, it will be going by 2 because 72 goes by 2. So you have to continue with the smallest one. If it is not, for this 45 it is not divisible, copy paste it, and for the rest of the numbers keep dividing it. Okay, so it is still going by 2. Okay, it still goes. We keep on doing it until there is no more factor which is like 2 can be taken. Okay, so the next will be 3, so it will be 15 here and 3 here, then again 3 can be taken, so 5 and 1 here, and in the last 5 can be taken, so 1 and 1 here. Okay, I hope you understood this method. Now to write the LCM is direct now. Previously we were writing both the prime factors and taking out common. In this we are directly writing LCM is equal to, we have to write all the numbers, there is no common you are going to take. Okay, so this is 5. Now I hope you remember, I have told you that always keep this 5 and 2 together, so this becomes a 10, and now multiply the rest of the numbers, so you'll get 24, 72, so it will be 720. Okay, so I hope you have understood this, that LCM will be 720. I've just multiplied it and nothing else. Okay, so this is how we can also find the LCM without using the prime factorization, or individually we can take both of them at the same time. Okay, now let us start with the SCF finding. Okay, now SCF is basically the highest common factor. The highest common factor. Now the highest common factor I have already covered in part 1, what is a factor and so on. So I'm going to take a simple example. Suppose we have this 24 and we have 60. Okay, now I want to write the factors of 24. I'm going to write the factors, so they will be like, 1 is a factor. Okay, it's a factor. 2, okay, 3, and then we have 4, then we have 6, 8, 12, and then 24. I hope you remember I told you that factors are always finite, so you cannot have more than this. Now for 60 we are going to write in the same way, 1, 2, what all numbers that can divide 60, I'm writing those. Okay, 5, 6, okay, then it will go by 10, it will go by 12, then it will go by 50 also, then 20, and then there's 30, and then it's 60. After half of the number you will never get any factor in between. Okay, this is the trick. So 30 is half of 60, you will never get any number between 30 and 60. Because you have got all the factors, just notice now we can directly see which is the highest number that is there in both of these. Okay, so we have got what all the numbers are there. So we have got 6 here, 6 here. Okay, do we have any other number? No. So the highest that is we are getting is, okay, 12 is there. So the highest of these two, so these are the common factors. Okay, the common factors are, 1 is there, but I'm not considering it. Generally 1 can divide every number, so it will always be there. Okay, so just see the highest for them, highest is 12. This implies your SCF is 12. I hope you have understood this. This is what SCF means. Okay, now see, many of the times it happens like we see this, okay, then how can we find it suitably and easily? So I'm going to take the methods of finding SCF. Okay, I'm going to take two numbers and I'm going to apply the factorization method, the prime factorization method. And we can apply prime factorization method here also. Okay, so what we do in this, we have this 24 and we have the 60, suppose. Okay, and we want to find the SCF. Okay, so we have this 24 and we have the 60 and we want to apply this prime factorization method. See how easily we can do this. We have this 2, 12, 2, 6, 2, 3, 3, 1. 60 we have 2, 30, 2, 15, 3, 5, 5, 1. Now we have got all the numbers and we have got all the factors. So what we are going to write, we are going to do this 24 is equal to 2 cross 2 cross 2 cross 3. And for 60 also we are going to do the same thing, 2 cross 2 cross 3 cross 5. Now remember that the highest common factor for these two numbers will be those numbers which are present in all of these pairs. Okay, so this is there, this is there, okay, and okay, this is also there. Fine. So we have to just write the SCF. Only we have to write this time the common values. Okay, LCM we have written all the values that are left also, but in this we only write the values that are there in all the numbers. So this will be 12, and we have found the same previously also. Okay, now this is one of the method. I'm just going to take the second way of the second method. Okay, so the second method is the division method, also called as long division method. Now in this, what we do, we basically keep on dividing the number, and we always divide the two numbers like this. Suppose 24, 60. We always divide till we get the highest value, which is just equal to this number or less than this number. So we know that 24 2 times give us 48, and that is the utmost value we can get. So we will get 2 and 1. Now we make this as our divisor and we copy the number 24. Okay, so it will be 12 to 24. It's a very simple example. It actually divides just in second step only. So whatever number which divides completely in the last step is the SCF of the two numbers. So the SCF of the two number is 12. Okay, but this was very easy number and hence we have got that. I'm just going to take one different. Okay, so let us consider some other example. So suppose we take 81 and 237. Okay, so we are considering 81 and 237. So you have to multiply 81, at most you can reach here. Okay, 3 times will give us 243 and that is 237, so more. So we will only take 2 times. So we will get, so this is 2. Okay, we will get 160. 162. We subtract it, we will get 5. 13 minus 6 is 7. Okay, 75. Now we again copy paste the number that was there as our first divisor, and now we divide it also. So 75 1 times 75, this becomes 6. Okay, now we take 75. Remember, you have to reach to the highest place. You cannot take 6 1 times 6 and then copy 5. It's not correct. So you have to multiply 6 to the highest value and reach till 75, and it is 6 12 times 72. Okay, so you get 3. Now once you divide 6, you will get 2 times 6, and hopefully the answer in this will be 3 only. Okay, I hope there's no problem any kind of. So you have understood how we take these two. Okay, so let us take another pair. I'm going to take a very big number this time so that it becomes more easy for us to understand. Okay, so let us take one more number pair. It is 1683 and 1584. Now we are going to write the smaller one and we are going to divide the larger one. Okay, so obviously this goes just one times, so we will get 1 5 8 4. This will give us 9. 17 minus 8, 9. Okay, there's nothing else, so you just keep like this and you then write 1584. Okay, since this number is very 1584 is very large, so we will do a rough calculation. We will try to find which is the number which will be very close to 1584. Okay, for this we normally divide at a rough place. Okay, so 594 5 times, I hope so it will be like very big. Let us check. 6 times, will it work? So we will get 4 here. Okay, it will completely divide it 16 times. So we will get 1584. And thus our SCF is 99. I hope you have understood this. Okay, this is like every time it will not happen, like in the second step it will cancel out, but yeah, this time it has come. Okay, I hope so you have understood this. Okay, this is the basic last topic, and from the next video onwards we will be starting with the Euclid's explanation and how we are going to write it in the exams. Okay, so this is just what we have done so far is the basics of solving this. Okay, now factor tree is basically very simple. You can start with any number and then you have to break it down using the prime factorization method, and you have to draw it like a tree structure. Okay, now suppose we take a number 1176. Okay, let us take a number 1176 and let us just prime factorize it. Okay, so what shall we get? 2. We will get 588. So what we have to do, you have to write it like this. Okay, you have to write it like this is 588 and this is 2. Fine. Then again you break it down. So 588 will again be divided by 2. So I'm writing directly. So it will be 2, 2, 4, 2 9s are 18, 2 4s are 8. You can do it separately here. It's not a doubt. Okay. And then you can also, or you can directly just write 2. This is divisible by 2, so you write 2 1 2 2 4s are 8, 2 7s are 14. Okay, it goes very easily. Okay, now you see the sum of the digits is 12, which is divisible by 3. So this number is divisible by 3. Now divide it. 3 4s are 12, 3 9s are, now you know 7 and 7. So at the end you will get the answer. Okay, this is a simple factor 3, and this is how we draw. If in the paper it comes like draw the factor tree. So you can also do the prime factorization in the rough, and then you can show the factor tree in this way. Okay, by taking the number that has been mentioned. Fine. So this is all for this basics part. From the next video onwards we will be starting with the theorems, and then we will be taking the problems, actual problems. Okay, it's not that was just the example and how we are going to solve it. You just notice this, and then from the next video we will cover the main questions. Okay, thanks for watching. Bye.